Good morning. What Jay said really resonated with me. The thing that's really exciting about being part of Open Compute is seeing how the community comes together to make a change. And the change that really, I think, resonates with me personally is the ability to take the economics and the efficiency of hyperscale computing and really democratize that and bring it to the masses. And that's really why, since the very beginning of Open Compute 4 years ago, Intel signed up to be one of the founding members of this charter. We believed in the overall mission of the efficiency of hyperscale and data center computing. And since that time, we've made over 14 different contributions. We've spent effort developing board specs that we've opened up to the community. We've contributed to the Open Rack spec. We've worked on management specs, which are critical to be able to operationalize these systems at scale. We've contributed to the switch spec. We're looking at everything from the infrastructure to the management to the network and to the storage as ways in which we can contribute because they're important to us. But one of the things that I hear from the community is that the job isn't done, that there's a lot that still can be done to make it simpler. In addition, it requires investment to deliver solutions to the Open Compute community. And are there ways in which through various specs and new enhancements, we can find ways to broaden the applicability of Open Compute hardware? And so right now, there are over 40 products with key partners that are here represented in the room. Our goal is to continue to expand that through the introduction of new specs that target new workloads. Now, to make this happen, we have to start re-architecting the fundamentals of the data center. We have to start with compute. So when we look at compute, there are a number of specs that are in place today through Open Compute. We help to contribute to the Panther board, which is an Atom-based SoC spec. It's a single socket, and that head node can be used, for example, for certain lightweight applications or potentially as the head node for a cold storage system like you'd see in the Honey Badger spec or design. We also have contributed to the Leopard spec, which is a dual socket 16-DIMM Xeon system targeted toward Open Compute infrastructure. We also know that because of some of the infrastructure requirements in other data centers, a 19-inch rack is important, and that's why we contributed to the decathlete spec. And then, of course, there's Winterfell, where now we're at generation 3.0 with the latest Xeon E5 V3s. And in fact, those decathlete and Winterfell specs now are delivering 2x the levels of performance that they were before. So our goal is to continue to make sure that the investment in infrastructure is updated through the delivery of new specs. Now, there are a number of companies that are delivering hardware already that are compliant to these specs, and that's really critical to make sure we have a robust ecosystem to deliver solutions. But one of the things that's really gaining momentum now is the adoption of those specs, and that's critical and probably most likely to happen in the compute space because that's where the specs and the infrastructure have been out in the industry the longest. And as an example, we've been pleased to see that Riot Games is now deploying their games infrastructure on Open Compute V2-based hardware using the windmill boards in the Winterfell infrastructure. They get about 46 systems into a rack at about 8 kilowatts. So they're very, very pleased with the results. But obviously, the goal is to make sure that we have a healthy ecosystem. We have to continue to broaden the applicability. Now, one of the requests that we've heard from the community is that something like an Atom-based SoC is great from a density and a power perspective, but really what was required for certain workloads is what I would call greater compute density, taking the capabilities of an SoC, but yet delivering the performance that people have been accustomed to, both in terms of single and multi-threaded level of performance. And that's really why we're very pleased to be here today to introduce the new Xeon D SOC processor. This is the first of a kind from Intel. We took the SoC and what we call the Uncore, the I/O architecture, and those IPs that we've had in our SoC roadmap. This is our first generation SoC. But what makes it unique is this is the first time that we brought the performance of the Xeon Core into the SoC product line and the family. And just to give you a bit more details on the product, The ones that we're introducing today have 8 cores. They are multi-threaded, so you can get up to 16 threads per SoC. The performance impact, as I mentioned, is substantial. You can get over 3x the performance versus the previous generation SoC processors, and obviously improved performance density as a result. We're integrating dual 10 gig Ethernet into the SoC, and this will be able to support up to 128 gigabytes of memory. So it's a very substantial horsepower despite its tiny package. Now, to talk about how we're going to go bring this to the community, I'd like to invite Jason Taylor to join me up on stage. He's the Vice President of Infrastructure at Facebook. Please help me welcome him. Hey, Jason, thanks for joining me. So talk a little bit about the spec that Jason alluded to.
That image you saw earlier, Jay Parikh talking about our servers, that was not a CAD rendering. We actually have built the server. It's in testing in our facilities. And we've been working with Intel for the last 18 months to deliver a SoC design to the data center space. And right now we're mid-collaboration. We're looking for a dense version of this processor, and I think we're going to get really phenomenal throughput per watt performance. And so when you're really looking for performance at scale and power efficient, this SoC design's, I don't know, we're pretty excited about it.
That's great. So what kind of application are you looking to use it for within the Facebook infrastructure?
Yeah, so when we design for Facebook, whenever we design a new SKU, we really stick just a limited number of server types. Our Type 1 server is focused on our web server, and we're looking for this to be a Type 1 replacement. So when we do hardware design, we put blinders on, and we really only focus on one workload. And so for the web tier, it's always the most performance per watt, and really just how do you put that disaggregated vision, how do you get that maximum amount of compute online and functional in a data center with as few residuals as possible. And one of the nice things about the SoC design is that so many of the regular components that you're always popping on motherboards are in the package. And so that efficiency really enabled us to go from a 2-piece system to a 1-piece system. And from a systems perspective, from an operating system perspective, you're dealing with one processor, one cache, not having to futz around with NUMA. We think it's going to be a really a nice step back towards simplicity that'll yield really good wins in the future.
That's great. And are you happy with our collaboration and our ability to be able to bring this to the...
Of course I'm happy, okay. Jason.
Great. That's good to hear. It's all that matters. Thank you, Jason.
Thank you.
Thank you very much, Jason Taylor. So, you know, again, it's about taking the infrastructure and realizing that there are new workloads or the workloads need to evolve, and then the hardware specs and the optimization points need to evolve with them. So we are looking forward to making the monolake board and the spec available to the open compute community. Now, looking almost at the other end of the spectrum, some of the other requests that we've got from the community is how can we make sure that we're delivering the top end of performance within the open compute infrastructure. And there are a number of companies within the open compute community that want to do scientific research, that want to do high performance computing, but the form factors and the density can be quite challenging. Well, we took that problem head on, and we've worked with the community to take a new board, and what's called the Adams Pass board, and this is a spec that we will also be opening up to the community, which is a half-width board, but it's able to support the Xeon Phi next generation processor. This will be available in the second half of the year. And what this processor can support is 60 cores, and that 60 cores can deliver more than 3 teraflops of double precision performance. So a tremendous amount of high performance computing capability, but fitting within the open compute rack design. And one of the things about this is that when you look at standard servers that have a GPU add-in card, you can get much better power efficiency. You can actually get 10 gigaflops per watt out of this motherboard spec and design versus doing something, and it's about 25% more efficient than what you'd get from a add-in card type of solution. So again, trying to make sure from a compute perspective, you've got dense designs that are compute optimized with the Model Lake board. You've got the Adams Pass board at the high end on high performance computing, and then Leopard for sort of the mainstream dual socket Xeon space. So it's not enough to just focus in on compute. We obviously see an increase in the demands for networking, and the overall density of the architecture can be improved as well. So there are a number of things that we're contributing to the community to improve. First of all, we've already contributed to the top of rack switch specs and the 10 gigabit open compute adapter, which has been very popular and seen a lot of uptake in the community as a whole. But what we want to do is improve upon those. So taking the adapter, we're now delivering a 40 gig adapter that'll be compliant to the Open Compute 2.0 design spec. But we're also recognizing that many of the servers, when we look at a next generation rack, are going to require improvements in cabling and improvements in density. And that's why we're also introducing a distributed switch. This is a switch called Red Rock Canyon. And what it allows you to do is do PCI Express switching within the chassis itself. And what that allows you then to do is have 100 gigabits to the sled or to the tray, and then be able to do 50 gigabit to each of the individual server nodes. Now, to go manage that, we're actually opening up software, which we're calling the Open Network Platform Switch software. And this is a combination of Linux-based drivers in combination with management tools that can allow somebody to manage all of the infrastructure and the distributed switches within the rack, while at the same time reducing the amount of cabling and the complexity of the infrastructure. One of the other goals that we set out to do in the interest of reusing the Open Compute hardware is that there's a trend toward network function virtualization. That more and more of the comms service providers that are here in the room have told us that they would like to be able to use standardized infrastructure to be able to run their network functions. And what we've been able to do, and you can see actually in the Intel booth, it's a Quanta-based demo later today, is you can see a decathlete-based board. So it's a standard open compute server running the Intel Open Network Platform server software. And so this essentially takes network function virtualization. It uses the Intel data plane developers kit, so you can accelerate some of those functions, as well as the Intel Quick Assist technology for security offload and acceleration. So really trying to make sure that we're delivering not just in the network space the hardware specs, but also supporting them with open source software. In the storage space, we have contributed the Panther board. Again, this is the Atom-based SoC board that you can use as the head node to the Honey Badger storage. So you might, for example, put 2 of those into the Honey Badger platform. That would support up to 30 SAS and SATA hard drives and up to 180 terabytes of storage. So a very economical way of driving scale-out storage. And in fact, Facebook has talked about how they use this for their cold storage or their photo tier within their infrastructure. But to me, what's really exciting about being a developer here in the room is the inflection that non-volatile memory offers to the industry. And so today, with the introduction of NVMe SSDs, you can replace up to 6 of the SATA-based SSDs that previously existed. And in this type of package where you could produce 2 terabytes within a non-volatile memory SSD that's PCI Express based, you could fit up to 48 terabytes of storage within a 2U design. So in a tremendous amount of high performance storage, that would deliver up to 11 million IOPS at a server level. So just a tremendous amount of performance. And the good news is that it's even going to be more compelling at the second half of the year. We're on the verge of introducing our 3D NAND technology. And just to give you a sense of how dense this is, we can produce a terabyte of memory in 2 millimeters squared. And that translates into the ability to deliver over 10 terabytes into a single SSD. We believe that when introduced, this will deliver between 2 to 3x the level of density, which obviously translates into both capacity and a cost advantage when it's introduced into the industry. So you have compute, you have network and storage, but for customers and the people that are looking to deploy solutions here in the room, it's about integrating all of those things together. And that's where we've been spending our time investing in the community, investing in designs around what we call the rack scale architecture. And the idea and the goal behind the rack scale architecture is particularly as companies are looking to deploy cloud-based solutions or infrastructure as a service, what they'd like to be able to do is view that rack as pools of compute, network, and storage, and actually allow the virtual machine to compose the resources that it needs to be able to deliver as a service. So there are a couple things that we're providing as part of the open compute community. The first is working with a number of different partners to deliver solutions that are starting to become available today. These are racks that essentially have high-density multi-node systems that share power, that share management infrastructure, and are presenting themselves as essentially disaggregated systems. The second piece to it is that we need to make sure that we allow more people to design. So we've got reference guides, but we're also providing reference code. And where the reference code comes in is that you need management APIs to be able to present that rack as pools of compute, network, and storage. And so we are introducing specs out into the industry, collaborating with a number of partners, companies like HP, as well as others, on the Redfish RESTful hardware management APIs. Those essentially allow you to do IPMI-based management in a RESTful state. And we want to be able to build upon those APIs at the rack scale APIs. The reference code that we then turn over to the industry is designed to allow vendors who want to be able to deploy those solutions to do so more readily. So we're working with a number of partners, and we're excited to see the adoption increasing in the direction of rack scale architecture. So just to summarize, there's a lot that we still need to do. We're excited to be a part of the community, and just as Jay said, we're looking forward to the next 4 years. There are things that you can do as part of this community. The first is we'd like to see you contribute specs and contribute to the specs. Make the IP, help make the specs that are being produced that come from Intel, Facebook, and others in the community, make them better, and help to make sure that we're turning them into designs that have a broad applicability, that can be deployed to a dense compute form factor, that can be deployed for high performance computing. That flexibility will make them both attractive to the end user community as well as produce a better return for the developer community. As users, we think that there's an opportunity to really gain efficiencies. We know that Facebook, Rackspace, Goldman Sachs, Riot Games, and others are seeing the gains that come from deploying open compute hardware. We'd like to see what we can do to help facilitate that deployment of solutions. And you can see we have a great range of ecosystem partners to help make that happen. And if anything here piqued your interest and you'd like to see more of it, please come to our booth. You will see what we're doing on a number of board designs, including the one that Jason Taylor highlighted earlier today. You'll be able to kind of see the rack scale architecture, the open switch platforms in addition to the software. So there's a tremendous amount that you can see. Please do come to our booth and tell us how we can continue to make sure that our contributions matter to the open compute community. Thank you very much.